cardioesophageal sphincter does not close properly, it can allow for the regurgitation of your stomach contents up into your esophagus. And that's what's known as gastric reflux, acid reflux, or heartburn. So a faulty cardioesophageal valve will lead to heartburn. Now, heartburn, chronic heartburn is a serious medical issue because irritation of the mucosal lining of the esophagus has been linked with esophageal cancer. And esophageal cancer is probably one of the most aggressive and difficult to treat cancers that there are. Not a good prognosis for people that are diagnosed with esophageal cancer. We know that this constant irritation of the lining of the esophagus with gastric contents is something that predisposes individuals to cancer, and there's been a study conducted that was very interesting where researchers followed a group of bulimic women for a very long time, and these are women who had suffered from bulimia, which is making yourself throw up, for a long time, over 10 years. And what they found is in those women, there was a higher rate of esophageal cancer compared to the general population. So we know that there is a direct relationship between irritating the lining of the esophagus with gastric juice, whether it's by throwing up or just by having heartburn or acid reflux, that there does seem to be a correlation between that and developing esophageal cancer. So that's something that you might want to think about if you suffer from chronic heartburn or you know somebody that does. It is something that you should see a physician for because it can be easily treated with medication, but if not treated, it can lead to something much more serious and not treatable. So, again, the inside of the esophagus is stratified squamous epithelium. That's really what I need you to know on this slide. These slides are from regular anatomy, so I'm not going to make you responsible for all of the stuff that regular anatomy would have to know. But we do need to know that the esophagus is made of stratified squamous epithelium. And the reason is because this particular tissue is the most protective of all the epithelial tissues because it's multi-layered. So the fact that it's multi-layered means that you can lose a couple layers of cells and it's not going to be that big of a deal. The body also replaces this type of tissue very, very quickly. So any parts of the body that are exposed or could be exposed to the environment, mechanical damage, are going to be lined with this type of tissue, always. So you're going to find stratified squamous epithelial tissue in the oral cavity, in the esophagus, in the anus, in the vagina. Anything that has the potential to be damaged mechanically or is close to the environment is going to have this type of tissue lining it. It's just the tissue of choice. Moving on, submucosa and muscularis and the other. I'm not going to hold you responsible for knowing the exact histology. One thing I do want to make sure that we remember is that when we're above the diaphragm, when we're not in the peritoneal cavity, we don't have that outer serosa. We have an adventitia layer, which is just sort of like that spider webbing material from Halloween that just helps to anchor the structures to surrounding structures and the cavity walls. So the outermost covering or layer of the esophagus will not be serosa, it will be adventitia. So we're going to have the mucus layer, stratified squamous epithelium is what you need to know, submucosa muscularis, and then in the case of the esophagus, adventitia layer. And that's spelled out in your notes. It's in the second paragraph of your note sheet where it's describing the esophagus. In case you wonder, this is what your esophagus actually looks like. This is a cross section of the esophagus. A word that you need to familiarize yourself with is lumen. Lumen is a term that means the hollow part of an organ. The hollow part of an organ, a tube, anything in the body that has a hollow. So inside of a blood vessel is called the lumen. the inside of the esophagus, the lumen, inside of the intestines, the lumen. Anything that is hollow, the hollow part of that organ is always called the lumen in anatomy. So that's a word that you have to know. That's just a vocab word that you need to be familiar with. So on here we can see that here is my mucosal layer, here's my submucosal layer, here's my muscularis externa, and then this is my adventitia around the outside of it. So your esophagus is about, I don't know, 10 inches long, maybe. And it just connects your throat with your stomach. So your stomach is just a J-shaped enlargement of this tube. It's got several functions. It's a storage organ, obviously, temporarily stores the food that you're digesting. It's responsible for mechanical digestion, breaking your food up, churning it, making sure it gets turned into this paste that's called chyme. C-H-Y-M-E is the word for that. Chemical digestion. The only macromolecule digested in the stomach is protein. That's it. And several of you on the quiz missed that question. You put that all three major macromolecules were digested in the stomach. And a lot of people think that they are. It's not true. Protein is the only macromolecule that is digested in the stomach. Fats and carbohydrates complete their digestion in the small intestine. Okay, so only proteins are going to be digested in the stomach. The stomach, in addition to the columnar cells secreting hydrochloric acid and pepsinogen, they also secrete something called intrinsic factor. Intrinsic factor is needed for the absorption of vitamin B. So in patients that have stomach issues, whether it's an ulcer, cancer, alcoholism that's damaged the cells, gastritis sometimes, intrinsic factor is not being manufactured and released at high enough levels to allow the body to absorb vitamin B. And vitamin B is sort of our energy drug. We need it to make blood cells. It's an essential vitamin in the human diet. So a lot of people that have stomach issues will have to see their doctor every 4 to 6 weeks and get vitamin B12 injections so that they have sufficient levels of vitamin B in their bloodstream so that they can function normally.
They said they only break down
only protein. The only thing the stomach digests.
That's rock climbing.
Your diagram here shows the regions of the stomach, so hopefully you guys were able to label this, and if not, let's get that done now, and I'm going to add some stuff to this figure. So there's 4 main sections to the stomach, and on your diagram, those 4 main sections are number 1, number 9, number 2, and number 7, I think. Yeah, wait, hold on, let me make sure that's what it's going to do. Yeah, number 2 and number 7. The cardia region is the area immediately adjacent to the esophageal sphincter. So on your diagram, that would be number 1 would be the cardia region. The fundus is the top of the stomach, the curved part. On your diagram, it's number 9. The body is the main area of the stomach. It's defined by what we call the lesser curvature, which is the inside curve of the stomach, and the greater curvature, which is the outside curve of the stomach. And then last but not least, the stomach narrows at the bottom into what we call the pylorus. So the pylorus is the last part of the stomach, and we also have a valve there called the pyloric sphincter. So the pyloric sphincter is going to control what exits the stomach and enters the small intestine. So this diagram is a color version of what you have in your notes. So again, we can see the fundus up here at the top, the cardia here right adjacent to the esophagus. We can see that we have 3 layers of smooth muscle. We need to know why there's 3, because in all the other organs in the digestive tract, there's only 2. So why a 3rd layer?
Oh, isn't it to compensate for digestion?
It's got to work harder. It's got to have more force. It's grinding, it's smushing your food up.
It's to compensate.
So in order to get your food mechanically digested, meaning physically breaking it down, we need that extra layer of muscle in order to do that. So here's the body of the stomach defined by the lesser curvature over here, greater curvature here. Then we narrow into the pylorus. This is the pyloric sphincter, and then we enter the duodenum of the small intestine. So the duodenum is the first section of the small intestine. What?
So it's like 1, 2, 3, and then the intestine? The layers of the stomach?
No, if you would do a cross section of the stomach, so so the outermost layer is the longitudinal layer, and then there's a layer on the inside that circles the stomach, and then the innermost layer runs at a diagonal. That's what oblique means. Oblique means diagonal. So the 3 layers of the stomach, they just line the wall of the stomach. So if we would take a cross section of this, which I think I have on the next slide, you would see all the layers that are typical. The mucosal layer, and then the submucosa, and then the muscularis external layer is going to have 3 layers of muscle. It's going to have oblique, and then circular, and then longitudinal, and then you'll have the serosa covering it. That's what the histology is going to look like. So here, let me really quickly, let's add some stuff onto here. Okay, so I don't like to put the numbers down. I like to actually label my diagram. So number 1, this is the cardia region of the stomach. If you don't already have that filled in, this is the fundus. 8 is the greater curvature. Number 3 is the lesser curvature. Number 2 is the body of the stomach. I don't know what this is pointing to. Body, cardia, fundus, greater curvature, pyloric antrum, pyloric canal. Number 5 is
The valve.
pointing
The
to
valve, the pyloric valve.
this muscle. So a sphincter is a circular muscle that controls the opening and closing of some sort of a canal. So this is the pyloric sphincter. Pylorus, pyloric valve. So this would be, number 7 is going to be just the pylorus. So this section, this narrowing section down here is the pylorus. This will be the pylorus, pyloric antrum, and this is the pyloric canal, but you don't need to know those two. We just need to know these sections. So you can actually color code this just so you sort of know where it's at. So this area up here would be the cardia region adjacent to the esophagus. This area up here, and again, this isn't perfect, it's just sort of, that would be the fundus. Down here, where it narrows, will be the pylorus, and then the rest of the stomach is considered the body. So that's the body. Fundus and pylorus. Okay, and then this is the duodenum, and you guys should know the duodenum of the small intestine. Okay, 3 main things that the stomach absorbs. First of all, we need to make sure that we remember that as far as digestion, the only thing that the stomach digests is protein. That's it. Absorption. There's only really 3 things that the stomach absorption. How do you spell absorption? Absorption. I don't know. Absorption. The stomach absorbs caffeine, alcohol,
Oh.
and non-steroidal anti-inflammatory drugs like Motrin and aspirin. Okay? What? Yeah, but it's absorbed through the stomach. Okay. So when we're talking about this stuff being broken down, most of your nutrients, 90% of your nutrients are absorbed in your small intestine. These are the things that are absorbed in the stomach, meaning an abuse of these particular substances is going to lead to stomach problems. So you drink a lot of caffeine, a lot of alcohol, take a lot of Motrin, professional athletes,
How do you spell Motrin?
people that just are what? These are going to lead to potential stomach issues. Main causes of gastric ulcers are the overconsumption of these products. So, something that I would expect you to know for a quiz. What is absorbed by the stomach? What?
What happened when you did an ulcer?
It says
We're
right
going
there.
to talk about what's going to happen.
Those three.
Okay.
Just instantly.
Next thing we need to take a look at are the cells of the stomach and what they do. So let's go back to this
I'm talking
one.
about the paper you went outside for.
Ladies, take it to the back if you're going to giggle and laugh. I don't feel like listening to this. I don't care if you go to the back, honestly, to talk. I just don't want you doing it where everybody's distracted. Histology of the stomach, again, we switch from stratified squamous epithelium in the esophagus to columnar epithelium in the stomach. Columnar epithelium has the ability to differentiate, meaning that cells can do different things. So one cell can produce mucus, the one next to it can make hydrochloric acid, the one next to it can make the hormone gastrin. It's all the same type of cell, they just have the ability to specialize. So this is good for the stomach because the stomach has to make and produce several different types of secretions. Submucosa, typical. Muscularis layer, obviously we need to remember 3 layers instead of 2. And then it does have a serosa because it's in the peritoneal cavity. So the serosa, if you want to call it the visceral peritoneum so that you remember that's what it is, you can use either term. All right, so let's take a closer look at the histology and let's talk about what these cells actually do, because these are things that you're going to have to be familiar with. So here's the histology of the stomach. We can see that the mucosal layer is folded into these structures called gastric pits. And it's in those gastric pits that we have these specialized columnar cells that make all this different cool stuff. To the right, you can see a blown up picture of these gastric pits with the different types of cells that we need to know. So the mucus cells, neck cells, parietal cells, chief cells, smooth muscle cells, and G cells. We need to know what all of those cells secrete. That's important because then if something's not being secreted, we sort of know where to look. So let's make sure that we have these definitions somewhere. Surface mucus cells, they're the ones that are closest to the surface of the pit. You have a diagram of this in the worksheet that you have. So on the very front page of this worksheet is a blown up picture of the different types of cells in the gastric pits. And I asked you to write down, do some research and write down what these cells are responsible for. So here's a good opportunity for you to jot this stuff down. So these mucus cells make mucus. Why? Because if your stomach wasn't coated with mucus, it would digest itself. The contents of the stomach are more corrosive than battery acid. And you've seen what happens when acid from a battery leaks onto the battery, it corrodes it. The stuff in your stomach is worse than that. So we have to make sure that the tissue of the stomach is protected. Otherwise, it would eat through the stomach. So a very, very thick coating of mucus helps to protect the inside lining. Mucus neck cells are just sort of the precursors for the mucus cells. They're the parents. So the neck cells make the mucus cells, which then make the mucus. The parietal cells secrete hydrochloric acid. Same stuff that you work with in chemistry. Same exact chemical formula. Hydrochloric acid. Hydrochloric acid lowers the pH of the stomach for 2 reasons. First reason is to kill bacteria. The amount of bacteria that you ingest every day is mind-boggling. Millions of bacteria. Between what's on your hands when you grab your chips and put it in your mouth, what's on your utensils, what's on the food itself. You are constantly consuming bacteria. So, in order to keep you from dying every time that you eat, the acidity in the stomach kills the majority of those bacteria, but not all of them. Some of them are pretty sneaky and they can get by. The second reason that the stomach has to be acidic is to activate pepsinogen into pepsin, which is the protein digesting enzyme in the stomach. So on your notes, you might want to jot down next to digestion protein that the enzyme specifically responsible for that is called pepsin, P-E-P-S-I-N. The parietal cells also are the cells that release this intrinsic factor. And this is necessary, like I said, for the absorption of vitamin B. So necessary for forming red blood cells. So how are people diagnosed with vitamin B deficiencies? A lot of times it's because they come in complaining of tiredness, fatigue. They're tested, their hemoglobin's low. They have anemia. Well, then what can cause anemia? Well, then the doctor might ask, do you drink a lot? Yeah, I'm an alcoholic. Well, that's the reason that you're anemic, because you've ruined your parietal cells. You're no longer making any intrinsic factor. No matter how much vitamin B you consume in your diet, you can't absorb it, so now you're anemic. That would be a typical progression in a diagnosis.
So if the body doesn't absorb it, it just goes through your stomach
Yep.
and doesn't do anything?
Yep. Goes all the way through
How
from
do I
mouth
get
to
this?
anus. Don't absorb anything. And
does it not
there's several of these sort
Gotta
of
go
things,
upstairs to
these
Miss Farman.
factors that we need in order to absorb certain nutrients from our food. So if
Career counselor.
the machinery to make those chemicals is broken, if we have a genetic mutation that doesn't allow us to make certain things, then it can have other effects. So yeah, intrinsic factor is one of the main ones. I won't say most, a good majority of chronic alcoholics are vitamin B deficient. In fact, a lot of them will go to the doctor every 4 to 6 weeks to get vitamin B shots so that they can make red blood cells. Otherwise, they'd have a lot worse effects. Chief cells, these are the ones that make pepsinogen, which is a precursor to the enzyme pepsin. And then you have your G cells, which make gastrin. You gotta know that. Gastrin's your hunger hormone. This is the hormone that makes your stomach start growling, that makes your mouth start watering because you're thinking about food. And then your stomach is releasing all of these chemicals. So, when you don't eat and you're either thinking about food or you're smelling food and you start feeling sort of nauseous, it's because you can't stop your stomach from gearing up and releasing all of these chemicals, preparing for that food to come.
Wait, why does it say 3?
What?
It says 3.
3 what?
It goes 4, 3.
What?
Nothing.
What did I don't
the
know.
numbering.
The numbering.
Because I just misnumbered it. So the gastrin is the hormone that's it's your hunger hormone. All right, and that's where we will stop for today.
We could go back.
So let's go ahead and let's grab our case study, and let's at least, we don't have time, so we'll start with the case study tomorrow.
Half the.
I was like, she gone.
Cause I don't like that.